Hi there, this is Miss Barber. I'm providing for you a worked example of a direct proof. Example, the product of two odd integers is an odd integer. First, let's note that it is not sufficient to select a few specific odd integers, multiply them, and then decide that the results of a few examples is sufficient to prove true for the entire set of integers. With that said, a proof requires that you show the statement true for every product of any two odd integers. So let's begin. To write a proof, we begin by writing PF to indicate that's what we're doing. And then we're going to take two arbitrary odd integers. So I'm going to say let A and B be odd integers. Okay? So we'll write we'll say that there exists an integer R such that A is equal to 2 times R plus 1. That makes it an odd number. And an integer, I need another letter, T, such that B is equal to 2T plus 1. Then let's see what happens. Then the product of A times B is equal to, and A is expressed as 2 times R plus 1. B is expressed as 2 times T plus 1. We can multiply this, so we get 4RT plus 2T plus 2R plus 1. This actually doesn't quite show that we have an odd number, but let's simplify a little bit. We can factor out a 2 from the first three terms. So now we get 2 times 2RT plus T plus R plus 1. Okay? Let's note that what's in the parentheses, 2RT plus T plus R, is an integer. And so we've actually shown that you've got A times B is equal to 2 times some integer plus 1 is an odd integer as required. Now, when you finish a proof, you have to indicate that you're done. Okay? Typically, we write QED, which means you've proven what you were setting out to prove, or you can also write a little square, and that also means that you have proven what you have set out to prove.